In this presentation, a comminuted fracture of the mandibular body will be treated with load-bearing osteosynthesis using a 2.5 mm thick matrix mandible straight reconstruction plate after simplification with 1.0 mm thick matrix mandible adaptation plates. The learning objectives of this presentation are the basic principles of the matrix mandible plate and screw system, and the correct application of a matrix mandible reconstruction plate and the supporting adaptation plates to repair a comminuted fracture of the mandible. The matrix mandible plate and screw system can be used for all mandibular trauma and reconstruction indications. All plates feature conical locking technology for a reliable screw-to-plate construct. The plates are available in thicknesses of 1.0 to 2.8 mm. In this exercise, a 1.0 mm thick adaptation plate and a 2.5 mm thick reconstruction plate will be used. Locking and non-locking screws are available in diameters of 2.0 to 2.9 mm. In this exercise, 2.0 mm non-locking and 2.4 mm locking screws will be used. One screwdriver blade fits all the screws. All of the screws can be used with all of the plates. All of the plates, screws and instruments are color-coded. The matrix mandible reconstruction plates combine all the advantages of a conventional reconstruction plate with the locking principle. The thread in the plate holes provide rigid anchorage for the locking screw. This construction acts as an internal fixator. The conical locking screw head allows for screw plate angulation. The amount of angulation depends on the screw diameter and plate thickness. In this case, a 2.4 mm locking screw is shown in combination with a 2.5 mm thick plate. This combination allows for a minimum screw angulation of 10 degrees. A non-locking screw can also be used in combination with this plate to allow wider angulation, which can be an advantage in certain clinical situations. The advantages of the locking system are: an exact adaptation of the plate to the bone is not needed. The plate exerts no pressure on the bone, and the risk of screw loosening is reduced. Routine diagnosis of this type of fracture should include X-rays taken in two planes at 90 degrees to each other. The minimum requirement is a PA view and a panoramic view. CT or digital volume tomography (DVT) imaging is extremely useful in cases of comminuted fractures. A submandibular approach is used to expose the entire fracture, so that the reconstruction plate can be anchored by at least 3 screws on either side of the comminuted area. Care is taken to avoid the marginal mandibular branch of the facial nerve. The comminuted area is shown on the model. Maxillomandibular fixation, MMF, is performed with arch bars. First, an arch bar is placed on the non-fractured maxilla. Then, an arch bar is placed on the fractured mandible. The arch bar is cut to length. Wiring starts from the stable portion of the mandible. The arch bar is passed between the wire ends and secured to the teeth. Each tooth should be ligated to the arch bar. The comminuted side is wired to the arch bar in the same manner. It is critical to recreate normal occlusion before fixation. The instruments needed for the adaptation plate are the cutting pliers, 2 bending pliers, a 1.5mm drill bit with 6mm stop, and a self-holding screwdriver. Adaptation plates can be used to simplify the smaller fragments in the comminuted zone into one large fragment. A long adaptation plate can be cut. Or, in certain cases, smaller plates or lag screws can be used. Here, a long adaptation plate is cut with the cutting pliers to create a 3-hole and a 4-hole plate. After the plates have been cut, there may be sharp edges or burrs remaining. The plates can be deburred using the diamond file located on the jaw of the cutter. The plates are contoured using the bending pliers. The 1.5mm monocortical holes are drilled. The non-locking 2.0mm screws are inserted. The screws should not be inserted too close to the fracture lines. The plates are used only to align the fragments. The simplification is finished off by applying a second plate. A 12-hole, 2.5mm thick matrix mandible straight reconstruction plate is used to bridge the comminuted area. The plate has to be long enough to allow at least 3 holes to be used for anchoring on either side of the comminuted area. When there is not enough space to place at least 3 screws posterior to the comminuted area, an angled reconstruction plate can be used. A bending template will make it easier to contour longer plates. The instruments needed to prepare the reconstruction plate are 2 shortcut plate cutters, the plate bender with nose, and the bending irons. If necessary, the shortcut plate cutters can be used to trim the plate. After trimming, the plate can be deburred by rubbing any sharp corners or edges against the recessed diamond file located in the handle. There are 3 steps to plate bending. First, in-plane bending. Second, out-of-plane bending. And finally, twisting of the plate. In regions where more extensive bending is planned, bending screws may be screwed into the plate prior to bending to prevent deformation of the plate holes. After the intended bend has been made, the bending screws are removed. In this exercise, bending screws are not used. The bending pliers with nose are used to bend the plate in 2 planes. In the first step, the plate must be bent in plane. The opening marked first step is used. The plate must always be bent between the plate holes. The plate is gradually guided through the opening according to the curvature required. For bending in the opposite direction, the plate must be reversed. After each step, the plate is checked against the template. In the second step, the plate is bent out of plane. The plate is inserted into the opening marked second step. Once again, the plate is gradually guided through the opening according to the curvature required. The end of the plate can be bent using the nose of the pliers marked last hole bend. As an alternative, the in-plane and out-of-plane bends can also be done with the bending irons. To do this, the bending iron etched with R should be held in the right hand, and the bending iron etched with L should be held in the left hand. The plate is positioned in the pocket etched 2.5, 2.8 of both bending irons. The plate is secured in the pockets by moving the sliders over the top of the plate. For in-plane bending, the handles are kept in plane and the desired bend is made. Out-of-plane bending can be done with either the same pockets or the slots in the head of the bending irons. The bending procedure is completed by twisting the plate. A twisting motion is applied until the desired torsional bend is achieved. The contoured plate is checked against the template. To apply the plate, the following instruments are used: 2 holding forceps with ball tip, the 1.8 drill sleeve with thread, the 1.8 mm drill bit, the depth gauge, and a self-holding screwdriver. The plate is fixed to the bone with the holding forceps. The plate must be flush with the inferior border to prevent any screws from going into the inferior alveolar nerve. To guarantee precise axially centered drilling and an accurate fit of the locking screw in the plate, a 1.8 drill sleeve with thread is screwed into the plate hole. The hole is drilled with the 1.8 mm drill bit. The drill sleeve is removed, and the length is measured with the depth gauge. A 2.4 mm locking screw is inserted. A second screw is inserted at the other end of the plate using the same procedure. The forceps are removed. At least 3 screws are placed on each side of the comminuted area. Large bone fragments in the comminuted area can also be secured to the plate. Here, this is done using additional locking screws. The large fragment is reduced. The hole is drilled with the 1.8 mm drill bit through the 1.8 drill sleeve. The drill sleeve is removed. After measuring the depth, the appropriate length 2.4 mm locking screw is inserted. If needed, another screw can be inserted using the same technique. The MMF is removed and the occlusion is checked. With the reconstruction plate in place, the fracture is now functionally stable. The reconstruction plate bridges the comminuted area. It is important to know that no form of compression has been applied. The result of the procedure is shown on the post-operative X-ray. This presentation has shown the basic principles of the matrix mandible locking plate and screw system, simplification of the comminuted area with 1.0 mm thick adaptation plates, and fixation with a 2.5 mm thick reconstruction plate.